All right, so we're at our second to last section for this probability, intro to probability unit, and it's going to be about probability tree diagrams. And so in the previous lesson, we worked more with like the formulaic way to go about it, and you can create a two-way table, etc. But now we're going to go from just a written description and then applying our formulas from there. So this is more common on the AP exam, is to just have a description and then finding the probabilities indicated. So let's go ahead and look at this example here. Many employers require prospective employees to take a drug test. A positive test result on this test indicates that the prospective employee uses illegal drugs. However, not all people who test positive actually use drugs, right? You've heard of the false positive. Well, suppose that 4% of prospective employees use drugs. The false positive rate is 5%, and the false negative rate is 10%. So let's go ahead and make a probability tree diagram. So again, we need to define our events. So we are going to use the following. So we're going to be, let's go with D for that the employee uses drugs. The employee uses drugs. And we're going to let event T be that they test positive. So those are our two events here. So we have to look, right? What happens first? Do they test positive and then they use drugs? Or do they use drugs and then they test positive? So that's a good differentiation point, is that here, right, 4% of them use drugs. We don't actually know how many of them test positive. So we're going to just use our first branch here, is whether they use drugs or they do not use drugs. And I was told that 4% use drugs, which by the complement rule means that 1 minus 0.04 is going to be 0.96. And for some reason here, my pen has decided to freeze. So here we go, 0.96, something like that. Oh, we are still glitching, of course. All right, and then from here, we're going to have the next branch of events. So let's see, why are we not? Oh, okay, there we go. Sorry, y'all. Awkward life pause. Okay, so here is that they test positive given they use drugs. Here's that they do not test positive given that they use drugs. They test positive given they do not use drugs. And they do not test positive given they do not use drugs. So we were told that the false positive rate, meaning that someone tests positive when they should not have, is 5%. So if they test positive when they should not have, that's going to be down here. And again, T and T naught are complements of one another. So the probability that they test negative, given that they do not use drugs, is fairly high at 0.95. And then the false negative, meaning that the test doesn't pick up that they use drugs, but they actually use drugs, that's about 10%. Which means, again, by the complement rule, the probability of testing positive given that they use drugs is about 90%. So we have our probability tree diagram here, and we see 4 different pathways. They use drugs and test positive. They do not use drugs and they test positive. They do not test positive and they use drugs. They do not test positive and they do not use drugs. So four things going on here. So let us figure out now these events. So what percent of people test positive and use illegal drugs? So this first probability is the probability that they test positive and they use drugs. Well, remember our conditional formula is that the conditional probability is always equal to the intersection over the condition. So here I have 2 of these 3 events. So to find the probability they test positive and use illegal drugs, I'm going to multiply the conditional probability by the condition. So the probability they test positive and they use drugs is 0.9, and the probability that they use drugs is 0.04, which tells us that the probability that they test positive and use drugs is going to be about 0.036. So of those 4% of people that use drugs, 90% of them test positive. So the probability that you test positive and use drugs is about, if we move that over, 3.6%. Okay, next one. What percent of people test positive? So we have to look here, right? I'm looking now for event T, the ways that you can test positive. Well, of these 4 pathways, the first way to test positive is that you actually use drugs. So here's my first pathway. The other way to test positive, we see, is if you do not use drugs, right? A false positive. So we have these 2 events here that will give us the probability of testing positive. So we're going to just multiply these and add them together. So what do I mean by that? Let me show you. And again, a lot of these rules, they just feel kind of like, what is happening? But again, I'm going to bring in the two-way table just because it helps us to visualize what's going down. So here we've got testing positive, not testing positive, uses drugs, does not use drugs. So the probability that you test positive is going to occur right here, right? These 2 events that we've defined. So you test positive and use drugs, or you test positive and you do not use drugs. So those are the 2 ways, which is why we're going to combine them. So this total probability here of testing positive is going to be those who test positive given they use drugs, plus those who test positive given they do not use drugs. So that's going to give me something along these lines. I already know this first probability because we found it in part A. And then we're going to add the second probability of testing positive given you do not use drugs, which we know is a 5% probability, and then not using drugs is 0.96. So the probability that you test positive is going to be about 0.084. So the probability of testing positive, regardless if you do or do not use drugs, is 0.084. So now that brings us now to our last bit here. What percent of people use illegal drugs given they test positive? So what percent of people use illegal drugs, and then look at that keyword there, given that they test positive? And at first it's tempting to select T given D, but that was already given to us. They wouldn't ask us to find something that we were already given. So we're finding the opposite. So this assumes that we know that they use drugs. But now we're looking the other way, probability of D given T. So now we're just looking D given T. So now this top box out of the entire event of T here. So the probability that someone uses drugs given they test positive can be found using the following formula, right? This is a conditional probability. So we know that in the numerator, we're going to have the intersection, D and T and D doesn't matter, and our conditional is that they test positive. Well, lucky for us, we've already found both of these probabilities, and a majority of the exercises on the AP exam are going to be the same way. They're scaffolded so that you use part A and part B there in part C. So the probability that they use drugs and they test positive, we saw was 0.036 over the probability they test positive, which is 0.084. This is going to give us an approximate probability of about 4286. Meaning that given that they test positive, the percent of people that use illegal drugs is about 42.86%. And we saw that from these 2 probabilities here. So you could fill this in on the two-way table, but these decimals get a little gruesome, so I don't recommend it. But essentially the two-way table shows us, right, here's each intersection of the events, and then the probability tree diagram shows us the progression of getting to those events. So that's kind of like a Mod Podge of the formulas and the representations for conditional probability. All right, so again, you saw written description. We defined our variables, which we did here. We created that representation, and then we just applied our formulas as needed. Now, here's another example for you. So I'm going to give you a few moments here to try this example out. Remember, define your events, make your representation, use your formulas. So I'm going to give you a few moments here to try out example 2. Okay, so hopefully you were able to at least get your tree diagram down and your variables. So I was told that 20% of the storms that originate in the Atlantic Ocean will be classified as major, and 20% of those storms occur in the Atlantic Ocean, 30% in the Eastern Pacific, and then 50% in the Western Pacific. So from there, using the complement rule, I can find each of these conditionals. So I've got all of these events here. So the next thing here says, what is the probability that a randomly observed tropical storm will be classified as major? So I look for all the ways that we can be classified as major. And so the first way is that from the Atlantic Ocean it's major. The second way is from the Eastern Pacific and it's major. And then the last way it's from the Western Pacific and it's major. So I have to do 0.2 times 0.2 plus 0.3 times 0.15, and you get the idea here. So here is the formula that I used. Here are my values substituted, and I determined that the probability of being a major storm is 0.21. Then from here, it says given, right, my conditional, that a randomly observed tropical storm is classified as major, what is the probability that the storm originates in the Atlantic? So P of A given that it's major. Again, the intersection is in the numerator, the condition is in the denominator. So the way we find A and M is we take the condition times its condition, the conditional probability times the condition we're given. So that's where I get 0.2 times 0.2. And again, that's just from our conditional probability formula. And we divide that by the probability of being major. So I get that about 19.05% of the storms that that are classified as major originate in the Atlantic. So again, you're going to get this written description. You're going to list your variables. You're going to create a graphical representation, and then you're going to apply your formulas when looking at probability tree questions or conditional probability questions. So that is going to pretty much sum up our ideas there of conditional probability. And in the next lesson, we're going to learn about types of probability. So good job. See you later.